This video is on quadratic transformations. The parent quadratic function y equals x squared can be transformed, and it looks like y equals a times the quantity x minus h squared plus k, where the vertex is the point hk. If a is greater than 0, the graph opens upward. If a is less than 0, then the graph opens downward. In other words, the basic parent function is reflected over the x-axis. If the absolute value of a is a number between 0 and 1, then the graph is vertically compressed. That is, it's wider and closer to the x-axis. If the absolute value of a is greater than 1, then the graph is vertically stretched, or it's narrower and closer to the y-axis. So a controls the shape and the orientation of the graph. If h is less than 0, then the graph is translated h units to the left. If h is greater than 0, the graph is translated h units to the right. If k is less than 0, then the graph is translated k units down, and if k is greater than 0, the graph is translated k units up. So h and k determine how much up or down, left or right, the parent function is transformed. So let's take a look at an example here. We need to graph the function y equals negative x plus 3 squared plus 4 and describe how it's a transformation of the parent function y equals x squared. So looking at this, I notice a couple things. I notice that a is equal to, a is equal to negative 1. So that means that my graph is going to open downward and my vertex is going to be a maximum. So that means that this graph is going to be reflected over the x-axis. Okay, I also notice that h is equal to negative 3. Now be careful, it looks like h is going to be 3, but remember that the formula is x minus h. H is whatever value is being subtracted from x. So this is the same as x minus a negative 3. So the value of h is actually negative 3, which means the graph is going to be translated 3 units left. And k is the value that's added out here. K is equal to 4, so that means that the parent graph is going to be translated 4 units up. Remember that h and k also give a vertex, so I can go ahead and graph those. So that's going to be the point negative 3, 4, and I know that it's going to open downward. And in fact, plugging in some additional points, the graph of the function is going to look like this. So, how is it a transformation of the parent function y equals x squared? It's reflected over the x-axis and it's translated 3 units left and 4 units up. Here's an example that takes it in the other direction. Here we have a graph and we need to write a quadratic function for the graph. So I need to write it in the form y equals a times x minus h, that quantity squared, plus k. Well, the first thing I notice is that my vertex is the point 2, 1. That gives me my h, and that gives me my k. So y is equal to a times x minus 2 squared plus 1. But what I don't know is what my value of a is. I do know that a is going to be greater than 0. I do know that it's a positive number since my graph opens upward. You'll notice I have another point on the graph. I actually know what the y-intercept is. The y-intercept is going to be the point 0, 3. So I can actually use that as an x-coordinate and a y-coordinate on the graph and plug that into here. So instead of y, I'll put in 3. And a is what I don't know. X is 0. I know that h is 2. And k is 1. And now I can solve this for a. So 3 is equal to 0 minus 2 is negative 2. Negative 2 squared is 4. So that's 4 times a plus 1. Subtracting 1 on each side gives me 2. And then dividing both sides by 4 gives me 2 over 4, or a is equal to 1/2. So this equation is going to be y equals 1/2 times x minus 2 squared plus 1. So in this video, we took a look at transformations of quadratic functions, what the values of a, h, and k do to the basic parent graph of the quadratic function y equals x squared. We did one example of graphing and describing those translations, and then we were able to write the quadratic function given a graph.